Hello everyone, this is a lesson on organic chemistry. In our last video, we looked at different homologous series. We looked at 3 in that video. In this video, we're going to look at the last 3. The alcohols, the carboxylic acids, and the esters. They are related in some way. That's why I've grouped them together. The alcohols has an OH, which is called a hydroxyl group. All of these functional groups have an OH. That's what's related about them. And then the general formula of the alcohol is CnH2n plus 1, and then you add an OH. The functional group for the alcohol, you'll have that hydroxyl group, the OH. When you look at a structure, it will have an OH. Sometimes it's not just one, there's 2 OH. But if it only has OH, then it's an alcohol. Now here is an example of an alcohol. It's an ethanol. Ethanol because it has 2 carbons and an OH. Then the name is ethanol. So for alcohols, when you write the name, you're going to write the OL at the end. Then when somebody is reading that name, will know that molecule, it's a alcohol because of the ol. The carboxylic acid. A carboxylic acid. When you look at the carboxylic acid and the ester, when you look at the general formula of the carboxylic acid and the general formula of the ester, they are exactly the same. So what will differ will be the structural formula, right? So the carboxylic acid, the general formula is like that. And then the functional group of a carboxylic acid has a double bond with an oxygen and an OH. So that's how you tell this is a carboxylic acid. It will have a double bond with the oxygen. The double is a carbonyl group. When they talk about the carbonyl group, they're talking about the carbon that has a double bond with oxygen. And this is a hydroxyl group. It's a OH. So this is the functional group of the carboxylic acid. You remember in our first video, when we were starting with organic chemistry, we were explaining that a functional group is that part of the atom that tells you in which homologous, which is the female, in which homologous series does it belong to. So here is an example of a carboxylic acid. It's an ethanoic acid. The carboxylic acid will always have the name acid. It's an ethanoic because it has 2 carbons. You remember in our first video, I said memorize the number of carbons and the name. Because there are 2 carbons, then it's ethanoic. Because it's a carboxylic acid, the name is ethanoic acid. So the general name will end with noic acid. Then you know it's a carboxylic acid. The esters, I've already spoken about the general formula of the esters. That is the same as that of the carboxylic acid. The difference is the esters, there will be a chain of carbons, and in the middle of the chain of carbons, there will be an oxygen that's breaking the chain. So it's making this group of carbons that will have a double bond with the oxygen carbonyl group. And then there will be a chain of carbons that don't have the carbonyl group. So the side where there's a carbonyl group, the double bond with the oxygen, that will be your main stem of the functional group. That's where you're gonna name it. And then the other side where there's no OH will be a branch, right? Let's look at this example. Do you see this carbon that has a double bond with oxygen is bonded to another carbon? Then that will be our main name. That's why the name says methyl ethanoate. This carbon that has no double bond with oxygen, it's 1. That's why it's methyl, it's the branch. And the carbon that has a double bond with oxygen has 2. It's 2 carbon bonded to 2. That's why it's ethanoate. And the part that you add is noate. So the name is ethyl ethanoate. Okay. In our next videos, we look at each homologous series and naming, how we name each homologous series. This is the end of our lesson. Thank you for watching.